Hello, my name is Eli Sharem. I'm a mechanical engineering student at the University of Houston. I'd like to welcome you to this presentation and walkthrough of the Study Buddy program. This program was developed by Andy Arago and myself as a National Academy of Engineering Grand Challenge under the category Advanced Personalized Learning. One of the stated goals of the Advanced Personalized Learning Challenge is to make learning more reliable. Science and technology are giving engineers the tools to tap into personalization, aptitudes, and customization that allow the educational system to transition from a one-size-fits-all policy to a personalized approach. If I had to describe our project in a single sentence, it would be that it's a matchmaking service for study partners. So I will say that our program isn't designed to make quality matches. Ultimately, that depends on the two students. It would be the same with friendships or marriages. Really, what makes a good match is determined over time and some experience. So if our program isn't trying to make good quality matches, what do we call a good match for the purposes of this program? Well, let me put it like this. What if I told you there were a few students on campus that have your exact same class schedule this semester? So I'd like to discuss the two different types of output data that are produced by this program. The first part is general information about the entire run of the program or simulation, and the second portion are results that pertain to a particular student. So in the general section, where next to the line where it says 5-star and it says 201, that means that there are 201 pairs of students in this simulation that share the exact same class schedule. A 4-star would be the number of pairs of students that have exactly 4 out of 5 classes in common, and so on. The section beneath is a section that will call up all the results for a particular student based off of their student ID number. Now, a student ID number in this program is just the number of the student. So in this simulation, there were 4,500 students that were put into the simulation, and the first student would be student ID number 1, and the last student would be student ID number 4,500. So in this second portion of the calculations, what's happening is the input is the particular student ID number, and the output is how many of each category of star matches they have, and then under that, a table of how many classes they have in common and with whom they have those classes in common. So the first line under the first match, where it says number of classes in common and student ID, it says that their student ID number 1 has 3 classes in common with student ID 15. Now, for the purposes of actually providing outputs for such a program, it would be an email or a message that gives a list of contact information, like an email of a student, and saying how many classes they have in common, even perhaps which ones, so that those students would be able to email each other if they wanted to and form like a study group. Well, that being said, let's take a look at a brief run of this simulation, and then we'll go through a specific test case where we can go through the different sections of code and see what they're doing. So in order to make a particular test case, it was necessary to remove the portion of code that generates course schedules based on the number of students and how many classes there are for them to register for. So we went ahead and set the number of students to 6, and we determined each of their schedules. So let's go through and see how all the results are calculated along the way. So the first thing that happens is these schedules are created, in this case loaded. And the first thing I will point out is that student 2 and student 4 have the same schedule. So we're going to expect those to be a 5-star match. Okay, let's go through the first for loop that's going to take each cell one at a time and create masks in order to find where in the rest of the schedules this class occurs for the case of this student. Okay. So going through column by column, these results are put in a variable called total. And as we can see, for the first class, class number 2, student 2 also has it. And we can verify that's true. So in the total variable, it is indicated by a 1, and so on. So when it gets to the end, in order to generate this variable, it's going to sum the total variable across and put that result into the first column, which would indicate the number of matches for the first student. So there they are. You'll see there's a 5 match for student 1. That means student 1 has the same classes as student 1. Well, that's data we want to remove. So that is taken care of in the next line. The loop runs through again, and it produces all the results for student number 2, as you can see here. And when it comes to removing that student, which is indicated here by a 5, it is also necessary to remove whatever is above it, because this 1 indicates that student 2 has one class in common with student 1, but that's already being counted here, where student 1 has one class in common with student 2. So executing this line of code, both of those values are removed. The loop continues until it's done all 6 students, and this variable will end up being a n by n matrix of however many students there are. So we let that run all the way, and we see all the values above that 1 student are removed. So for student 6, it's all zeros, but all of student 6 matches are in row number 6. This next portion of code is going to go through and count the total of each star category that there are in this results matrix. So we would expect that when it gets to 5, or when it's looking for all the 5s, it's only going to find 1. And those values are then going to be printed as the general results. So let's go through and execute those lines of code. And as you can see, it says there is only one 5-star match, as we expected. If we go ahead and verify that there are only that there are 5 2-star matches, we can go through and count these. There's 1, 2, 3, 4, and 5. And the same holds true for 1-star matches, 3s, and 4s. The next portion of code just finds where all the 4s, 3s, 2s, 1s are, and it holds those locations. The next portion of code is the part of the program that finds the results for any particular student ID number. So we get to the input and it wants to know what student do you want to look at. So we'll type in student number 1. And what's going to happen is the summing part now. When we enter student number 1, and only for student number 1, we want all of these answers to show up as the matches for student 1. So when student number 1 and only number 1 is selected, all of these variables are going to be put into their own variable. If student number 3 were selected, everything to the left going by row up until 3 would be stored in the student ID results left, and everything below would be stored in the student ID results down. Then those two are put together. So let's let the code run all the way to where they are combined. Once the student ID results are combined, the next row is initialized with zeros, and what's going to populate in this column are the student IDs of those matches. That is done with this for loop, and then the line is omitted for whichever student we are looking at. In this case, it's student 1, so now there are only 5 students left to compare to, and we can verify that. Once that is completed, those results using a for loop get printed to the command window, and the student ID results are then saved into an array that holds all the different students' results that were run. Once that is completed, the program will ask if we'd like to run another student ID. If we said yes and we entered in student number 2, for example, we know student 2 is going to have a match, a 5-star match with student number 4. So let's go ahead and see that. And we see that that is the case. It's a 5 match with student number 4. And so on. Once that part's run, it goes back to the menu that allows us to select another student. If we were to select no, the program would then ask if we'd like to run another simulation. and then all the results, the matrix, the n by n matrix, gets stored for export, and the results matrix for each simulation that's run also gets stored, ready for export. Thank you. This has been a presentation of the Study Buddy program.